All right, so now we're going to take a look at some actual examples of solving rational equations. So when you solve a rational equation, it is sometimes tempting to use cross multiplication. And the problem with that is how are you going to cross multiply this problem? It doesn't make any sense. So though it works with some problems, I don't use it because I like to be consistent. What I like to use is I like to use the LCD. Right? The least common denominator is used to eliminate the denominator from the problem and therefore make it so all you have to do is solve the remaining numerators. So the LCD of this problem would be the common number that these two numbers divide into, which would be 8. And also the variable, it also would have to be common. So this right here, again, the way a least common denominator works is you multiply what you currently have by what is missing from the LCD. So in this problem, you're missing the x from the LCD. So you would multiply it on the top and the bottom. And from this problem, you're missing the 4, right? Because 2 times 4 is 8. And now if you just kind of do a little mental check here, this is 8x and this is 8x. So both of those are now equivalent. So what you do now is you will simplify this, right? So you're going to distribute this one and multiply that one. So you'll get 4x plus 12. All right. And then that equals 5x. And that would actually be the same thing as cross multiplying. But again, when you look at this problem, cross multiplication is not going to help you. Technically, though, let's talk about algebraic rules here. Technically, there still is an 8x here, and there still is an 8x here. And you can cancel it out. And the reason you cancel it out is imagine you had a problem like this from a previous chapter. Okay? If I had this in a previous chapter, the fact that I have the 8x on both sides means that it will cross out due to the subtraction property of equality, right? I mean, you can show the work if you want to show that it cancels out. But if you don't have to, I mean, if you have the same thing on both sides, it has the same sign and term, they cancel out using the subtraction property of equality. Well, over here, we have the multiplicative property of equality, because if I multiply both sides by 8x, it would cancel out on both sides. So you don't have to show that step. You can just get to here and say, okay, I have the same thing being divided, the same term being divided on both sides, so it cancels. But that's the reason, is because you're using the multiplicative property of equality. So now we do just have the numerators, and now we just have an Algebra 1 problem, right? This problem right here is just an Algebra 1 or geometry problem to solve. I'm just going to move my variables to one side. Just going to move them to one side and then divide. So very simple, very reasonable problem, right? Once we know how to do it, it is the same thing, only different. And in fact, that problem is now done. Your answer is 12. There is one important thing to remember. We can't forget about domain restrictions. They do play an important role in solving as well. And the domain restriction here, you don't need to set 8 equal to 0. But if you set 2x not equal to 0, you would get that x is never allowed to equal 0. Why is that important? Because if your answer is x equals 0 and your domain restriction is that x can never be 0, there would be no solution. But in this problem, we're good to go. The way you would check this, by the way, is you would put the 12 back into the original problem. So if I put the 12 back into the original problem and had 12 plus 3 divided by 2 times 12, and I simplified that, that would come out to 15 over 24. And if I reduce this fraction, it should come out to 5/8. And remember how we've been talking about reducing fractions as we find a common multiplication fact. This is 3 times 5. And this is 3 times 8. And once you cancel out the common multiplication fact, that's how you reduce a fraction. I know that you didn't learn that in elementary school, but it is the most efficient and the most mathematically correct way to reduce a fraction. Okay, so let's take a look at how we would do this problem again that would not allow me to use cross multiplication. So cross multiplication, again, is something you learn in geometry, occasionally in Algebra 1. It is very ineffective because of its lack of use. You can only use it under certain circumstances. However, if you use the LCD, you will not have that problem. The LCD will work every time. So what is my LCD? Please remember that this problem has a 1 on the bottom. Okay, so it doesn't need to be part of the LCD, but it will need to have, be multiplied by a couple items. So this LCD would be 6. The smallest number that 6 and 2 divide into is 6, and x. So then I would come back and I would say, well, what is this missing to become 6x? It's missing 3x. What is this missing? It has to be the same. Remember, we don't really care about the numerator. Its multiplication is decided by the denominator. All right, so down here, this needs nothing. It is, in fact, the LCD, so it does not need to be changed, but this needs the entire LCD of 6x. This next step is really important to understand how it works so that you don't make a careless mistake. So we multiply the top here. We get 9x squared. The bottom is 6x. Then this doesn't change, so minus 5 over 6x. And then equals negative 12x over 6x. It is very important to combine these like terms before you cancel the denominators. So in this case, all I have to do is combine them and put them over 6x, okay? And then over here, I would have negative 12x over 6x. Though it may be tempting to reduce that, remember it would just reduce back to the original problem and would not help you. You reduce it by eliminating the denominators again, because we could multiply both sides by 6x to cancel it. But if you understand how properties work, you don't have to show that. You could just simply say that was done by the multiplicative equality property. So now you're left with this. Now you're left with 9x squared minus 5 is equal to negative 12x. And now we have a problem straight out of the most recent test we took on quadratics, right? It's the same idea. So what do we do with quadratics? We set them equal to 0. So I would add 12x to both sides. Set it equal to 0. And this problem will factor. Would you have to potentially do something other than factor? The answer is maybe, but the focus in this chapter is, can you solve a rational equation? So most teachers won't give you the most difficult quadratic equation on top of a rational problem. So I factor this using the box method normally. If you use grouping or what have you, you may. This is a great problem to do with the box method. I'm going to try for 9x squared, which is locked in. Remember, we lock in 9x squared. We lock in negative 5. I'm going to try 3x and x. Again, if it doesn't work, that's okay, right? That's what we have to learn about any method for factoring. There is a little trial and error. So 5 can only be created by 1 times 5. So we don't have a lot of options here. So I'm going to put a 1 here and a 5 here, and let's see what we have and see if we can get this middle term, which is the goal, right? Our goal in any factoring problem is to get our middle term. All right, so when I multiply this through here, this gives me 3x. This gives me 15x. And remember, this problem is about subtracting, right? We're trying to subtract these terms to get the middle term, which is pretty easy because 15 and 3 make 12 if this is negative. Okay, so it lines up, right? And then we get our two factors. Our factors are 3x minus 1 on the top, and then 3x plus 5 along the column. And then we set both these equal to 0 using the zero product property, which we learned very recently in quadratics and came up in the polynomial chapter. So we set both these equal to 0, and then we solve. So this would be 3x is equal to 1. So x is equal to 1/3. Over here, we would have 3x is equal to negative 5, and then we would get x is equal to negative 5/3. So the question is, do these work? And there isn't really extraneous answers other than domain restrictions. So if I come up here and look, the domain restriction of this problem, again, I would set only the portion that has an x in it, not equal to 0, and I would solve for, as I said, the anti-solution by dividing by 6 on both sides, right? And so I just can't have an answer that's 0. So when I come down here, the answer is good. We don't have an issue. So we can go back to using our curly brackets. The smaller answer is 5/3. The larger answer is 1/3. And again, what do these answers mean? If I plug them into the original problem, which would be kind of complicated, I would get -2. You would clearly want to use some kind of calculator to do that. But you can already see, like, if you put a third in there, it's not so bad. If you put a third in there, you would have 3 times a third, which is a half, minus 5 times 6. times a third, which would be 2, and so you would get, yeah, it would come out to the right thing. Again, if you use a calculator to see that, then it would be a little clearer. But remember, there are no extraneous answers in this section other than answers that are the same as a domain restriction. So if one of these answers was 0, I would have to eliminate it and consider it extraneous.